The aim of practical to perform the heat balance test on the CI engine. To draw up a thermal energy distribution means the heat balance for the CI engine by the performing the load test at the rated speed of the engine within electrical brake dynamometer. Here the practical was performed on the single cylinder 4-stroke water cooled diesel engine. For the fuel measuring system consists of the fuel tank, burette and three-way cock arrangement. The air measuring system airbox method for the air tank fitted with an orifice and water manometer. For the measuring of the heat carried out, it consists of inlet and outlet piping with the flow control valve and the water meter and temperature sensor are provided to measure the inlet and outlet temperature of water. Here for the heat balance sheet. The performance of an engine is generally given by the heat balance sheet. To draw the heat balance sheet for the IC engine, it is run at the constant load. The quantity of fuel used in a given time and its calorific value is given the heat supply. The amount of cooling water and inlet and outlet temperature of cooling water was given the heat absorption from the IC engine at given time. The temperature of exhaust gases and mass flow rate of air and mass flow rate of fuel gases is given the hot gas energy with the help of the water calorimeter. Etc. are recorded in the experiment. After that, the heat used in the different section is calculated using our standard formula, which are explained in the calculation section. For the practical, we have required for the observing the engine shaft speed RPM, power developed by engine in kilowatt, atmospheric temperature in degree Celsius, temperature of water inlet of water jacket T1, temperature of water outlet to water jacket T2, temperature of water inlet to calorimeter T3, temperature of water outlet to calorimeter T4 and temperature of exhaust gases at inlet to calorimeter T5, temperature of exhaust gases at outlet to calorimeter T6 and time required for the 10 ml of fuel consumption. Also time required for filling up the 1 liter water collector from the water jacket and time required for the filling up the 1 liter water collector from the calorimeter. After that we calculate the heat supply in an engine, heat absorbed by water, heat absorbed by hot gases and power developed by IC engine means the brake power, and also we have calculated the unaccounted losses. This is our diesel engine setup for performing the heat balance sheet and Williams method. This is our 4-stroke water cooled diesel engine. This is connected with the electrical dynamometer which is connected with the crankshaft. You can see the tachometer, which is our use for the measuring the crankshaft RPM. It is a spring balance coupled with the dynamometer for the load condition. Here you can see the one test rig attached with the IC engine, which is consist of fuel tank, air box, and burette for fuel consumption. It is also display the temperature and RPM. You can see air box for the measuring the air consumption into the engine. The air is transferred to the engine from the air box by the help of the hose pipe. You can see this hose pipe. The fuel line, which is connect the engine to burette and burette to the fuel tank, which is supply the diesel. For the measuring the consumption, the tank fuel here here we open and close the valve for the measuring the diesel consumption. Here it is the gas calorimeter which absorb the hot gases. Here the temperature sensor for measuring the temperature of water inlet and outlet from the calorimeter. You can see the here the water control bar for the controlling the water flow. This is the load bank. It is a capacity the 4 kilowatt for apply the load and for the power down the all switch. Here you can see that switch down to on for the applying the load and remove the load UAV up the switch for the off condition. Different load are given. This is the water meter, which is measuring the water flow for the water jacket. The cooling water which absorb the heat from the engine. Before the start engine start the water flow. Here meter start. Take the initial and final reading on the analog counter for the 10 seconds for the measuring the flow rate. For the measuring the exhaust gas temperature, we can use the temperature sensor. In this sensor used for the inlet and outlet temperature of the exhaust gas. Here inlet temperature into the calorimeter. Here all the temperature sensor are the K type for the outlet condition. Here this is the way for the exhaust gas removed from the test engine. Now here you can check the initial diesel level before the starting of the engine. Here you have the initial mark for the starting engine and the second mark for the closed engine. So we calculate the total fuel consumption during the running period of IC engine. For the fuel consumption, we have take the mark 10 ml. How to take reading? First, start the engine. Here must be remove the handle for the safety purpose. Here we have a wait for the stabilizing the RPM before the start the experiment. Here some load applying. Here the connect load bank is connect with the dynamometer. This is our load bank. Now here we cannot apply the any load. You can see that its capacity is 4 kilowatt. Here you can see the RPM which is now stable. Here initial fuel level. Here we are check all the load condition, all the switch are off. Here we can apply the 1 kilowatt, but here we cannot apply directly 1 kilowatt, we can gradually apply. Here load increase on spring balance. Here we can apply 50 plus 50 100 plus 250 plus 250 means 1000 watt. Here also you can see in a spring balance. Here you can see that the RPM and temperature is changed when apply the load. Here we can measure the water column for the airbox method, and for the fuel consumption we measure the time for consuming the 10 ml fuel. Here start the time. Here fuel level reducing. We have achieved the 10 ml fuel consumption and we stop the our watch and take the reading. Here you can see that the diesel level reducing. Here now stop the watch for 10 ml consumption. Here we have a required 38 seconds for the consuming the 1 kilowatt power. For the Williamson line method, we have applied the 2 kilowatt, 3 kilowatt and 4 kilowatt load and measure the fuel consumption. Here we have take the all the readings for the heat balancing and the Williams lines method. At the end, we remove the all load. Here you can see that, and stop the engine. From the experiment, we will make the observation table. Here brake power is 1 kilowatt. Here for the 10 ml fuel consumption we have required 38 seconds. For the water flow rate for the water jacket is required 12 seconds. Second, water flow rate in a calorimeter is 1 liter for 14 seconds. Speed measurement by the tachometer is 1500 rpm. Here manometer difference for the airbox method is 8 cm. Ambient temperature is 25 degrees Celsius. T1 temperature means the water inlet temperature in a water jacket is 29 degrees Celsius and outlet temperature is 33 degrees Celsius. Temperature T3 means the inlet water calorimeter temperature and T4 is outlet water calorimeter temperature is 34 degrees Celsius. Exhaust gas in the calorimeter temperature is 127 degrees Celsius and exhaust gas outlet temperature is 82 degrees Celsius. From the lab manual, we have taken the data like density of water 1000 kg per meter cube, density of air is 1.21 kg per meter cube, density of fuel 840 kg per meter cube, bore diameter 85 cross 10 raised to minus 3 meter, stroke length 18 multiplied by 10 raised to minus 3 meter, diameter of orifice is 25 multiplied by 10 raised to minus 3 meter, specific heat of water is 4.2 kilojoule per kg Kelvin, specific heat for the gas is 2.1 kilojoule per kg Kelvin and calorific value of diesel is 42,000 kilojoule per kg. Calculation, first we have calculate all the flow rate. Our first flow rate is mass flow rate of fluid. Mass flow rate of fluid is equal to volume divided by time multiplied by V density. Here 10 ml we have required 38 seconds and density is 840. So mass flow rate of fluid is 0.002 2 kg per second. Second is the mass flow rate of water in a jacket. We getting the 0.0833 kg per second. Third, mass flow rate of water in calorimeter. Here 0.0714 kg per second. And mass flow rate of air by the airbox method, we have find that here A0 is the orifice area pi by 4 D0 square. Here we have taken the D0 is 0.025 meter. Here orifice constant 0.164 and the equation for the velocity under root 2gh multiplied by density of water and multiplied by divided by density of air for the conversion in water column to air column. So we get the mass flow rate of air is 0.0113 kg per second and total mass flow rate of gas is Ma plus Mf is equal to 0.0115 kg per second. Here for the heat balance sheet we have required the energy calculation. First our inlet energy is the heat supply. Its formula is Mf multiplied with calorific value. So we get the heat supply is the 8.4 kilowatt. Second is the heat absorbed by the cooling water from the IC engine is the sensible heat, so that MW mass flow rate of water, specific heat of water and the temperature difference. So we get the 1.75 kilowatt heat absorbed by cooling water from the IC engine and our power developed by the IC engine is the 1 kilowatt. Here heat absorbed by the hot gases with the help of the calorimeter. In a calorimeter we have supplied the cold water for absorb the heat. Here water flow rate, specific heat of water and the temperature difference. After that some energy is consumed the hot gases which is not absorbed by the cold water is the mass flow rate of gas, specific heat of gas and temperature difference between the hot gas outlet temperature and the ambient temperature. From this equation we getting the value of the heat absorbed by hot gas is 2.88 kilowatt and our unaccounted loss means the valve timing loss or the some crank mechanism loss, pumping loss. So these loss are calculated by the total heat supply minus heat consumption means the heat consumption by water, power developed by IC engine and heat consumption by the hot gases. So we get the unaccounted losses is 2.77 kilowatt. From that data we have prepared the heat balance sheet. Here supply heat 8.4 kilowatt 100%. Here supply heat is divided in a four part. First part in a water absorption, second part power developed by engine, third part heat absorbed by the hot gases and fourth unaccounted losses. Here heat absorbed by water is 1.75 means is consumed the 20.83 energy from the supply heat. Power developed by engine is 1 kilowatt. It consumed the 11.9 percentage from the total heat supply and the hot gas is maximum heat absorbed from the heat supply is 34.29 percentage and our unaccounted losses or unaccounted energy is called the 2.77 kilowatt. It absorbs the energy from the 100 is out of 100 32.98 percentage. Second aim of practical to perform the Williams lines method test on the CI engine. This method of determining the friction power and hence the indicated power of CI engine. It is based on the fact that at part load the combustion is completed within the engine cylinder. Hence, at a given speed, the rate of consumption bears a linear relationship with power output. A plot, therefore, of rate of fuel consumption versus power output at a particular speed will be a straight line. In the light load region, the straight line is Williams line and the amount of negative power output torque obtained by extrapolation of the plot at zero rate of fuel consumption represent the friction power, means the power required to overcome friction of the engine at a specific speed. Here we have used the same test trick. Here we have increased the load with the help of the load bank. We have applied the 1 kilowatt. The fuel consumption means the time for the fuel consumption of 10 ml we have required 42 seconds. For the 2 kilowatt load apply when we have required 32 seconds. For the 3 kilowatt apply we have required 24 seconds. For the 4 kilowatt we have required 17 seconds. In the calculation part we have required the fuel consumption in hour for the plotting the graph. Here fuel consumption is volume divided by time multiplied with density. For the first brake power we have required 42 seconds. So here mass flow rate means the fuel consumption is 0.72 kg per hour. When second observation, when we have required 2 kilowatt power, the fuel consumption is increasing. The value is the 0.945 kg per hour. For the third observation, whenever we have applied the 3 kilowatt power, the fuel consumption is 1.226 kg per hour. And when we have applied the 4 kilowatt load, the friction power is 1.778 kg per hour. Here we have plotted the brake power and the friction power. In the x-axis we have plotted brake power and y-axis fuel consumption. You can see that here x-axis brake power and y-axis fuel consumption. For 1 kilowatt we have required 0.72 kg per hour. Here for the 2 kilowatt we have required 0.945 fuel consumption. For the 3 kilowatt we have required 1.26. For the 4 kilowatt we have required 1.778 fuel. So here we have plotted the straight line and extended this line from this point to negative side. So we have a plot here. One point is called the friction power point. When the friction power value is 0.9 kilowatt, that point indicate the power required to overcome the friction. So here we have calculate the friction power with the help of Williams line graph method, and this graph was plotted in a Excel analysis. Thank you.